Welcome to The Explainer. So today, we're going to solve one of those classic kitchen mysteries. You know the one, why is it that some ingredients, like sugar, seem to do this amazing disappearing act when you mix them into water, but other things, like flour, just make a big cloudy mess? Well, the answer is hiding right there in your pantry, and it all boils down to some pretty cool chemistry.
And believe it or not, it all starts with one of the most beloved foods on the entire planet: bread. See, making that perfect loaf isn't just art, it's a science. And today, we're going to uncover one of its most basic, most important secrets.
I mean, just think about it for a second. You stir a spoonful of sugar into your coffee or tea, and poof, it's just gone. But if you try to do that same exact thing with flour and water, you get a totally different result, right? It's this cloudy, pasty mess. It's a super common kitchen puzzle, but yeah, there's a totally scientific reason for it.
Okay, so let's really get to the bottom of this kitchen conundrum. We're going to zoom in all the way down to the molecular level to see what's actually going on when these ingredients hit the water.
You know, the source material we're pulling from for this, a curriculum called Bake It, it makes this fantastic point. Baking, and really all cooking, isn't just an art form. It's chemistry. Seriously, every single thing you do, from mixing the ingredients to putting it in the oven, is basically a scientific reaction.
So, to really get to the bottom of our little mystery here, there's really only one thing for it. We've got to run an experiment. Yep, we're going to become kitchen scientists for a few minutes and see this whole process in action.
All right, here are our test subjects for today. We've got 4 really basic ingredients for bread making, all pulled from that Bake It curriculum. We've got sugar, salt, flour, and yeast.
And our method is going to be really simple and scientific, just like it's laid out in the source. We're going to add 1 teaspoon of each of these things to the exact same amount of water, give it a good gentle stir, and then just watch and see what happens.
Okay, but before we look at the results, here's your chance to play along. Make a quick prediction in your head. Out of these 4, sugar, salt, flour, and yeast, which ones do you think are going to disappear, and which ones are just going to hang around?
Okay, time for the big reveal. As it turns out, our super simple test shows 2 completely different things happening. And these differences, well, they let us put these mixtures into 2 distinct scientific categories.
So when we mix solids and liquids, we basically create different kinds of mixtures. And you can see the 2 main possibilities right here. Sometimes you get what we call a homogeneous mixture, where everything looks totally uniform and clear. Other times, you get a heterogeneous one, where you can still kind of see all the different bits and pieces floating around. And here they are, the actual results from our little experiment. And just like you might have guessed, the sugar and salt, they both formed a nice, clear mixture. But the flour and the yeast, they made a cloudy, murky mix. So right away, that tells us they belong in 2 totally different groups.
So, those substances that did the disappearing act are sugar and salt. They get a special name from scientists. They're called soluble. And all that means is that their tiny little particles can break apart and spread out super evenly all through the liquid.
And when a soluble substance dissolves like that, it creates a very specific kind of mixture. It's called a solution. See? It's not magic at all. It's just really cool chemistry. But this brings us right back to that big illusion, doesn't it? If you can't see the sugar or the salt anymore, did they really truly disappear? I mean, where did the particles actually go? And here is the absolute proof. Check this out. If you weigh the water, and then you weigh the sugar separately, and then you weigh the final mixture, the weight is exactly the same. The mass of the sugar is still in there. And that proves the particles didn't vanish, they just dissolved and spread out. Okay, so now let's talk about our other 2 ingredients, the flour and the yeast. Since they didn't dissolve, they get the opposite label. They're classified as insoluble. So instead of breaking down into all these tiny individual particles, the little bits of flour and yeast are they're just floating around in the water. They're mixed in for sure, but they haven't dissolved. And that's what makes the water look all cloudy.
And this kind of cloudy mixture has its own name too. It's called a suspension. And here's the key difference. With a suspension, if you just let it sit there long enough, all those little insoluble particles will eventually settle down to the bottom.
Okay, so we've got the science down now, solution versus suspension. But why on earth does a baker actually care about any of this? I mean, what does this have to do with making a perfect loaf of bread? Oh, it has everything to do with it. For a baker, this isn't just theory. This is mission-critical stuff. You need to dissolve the sugar to make a solution, because that's what feeds the yeast.
But at the same time, the yeast itself has to be suspended, not dissolved, in warm water to get it to wake up and start creating the gas that makes the bread nice and fluffy.
And this just brings us right back to that awesome core idea from our Bake It source material. The kitchen really truly is a laboratory, and every single recipe you follow, it's basically an experiment.
So here's the big takeaway. Understanding this super simple chemistry actually gives you control in the kitchen. You're not just blindly following a recipe anymore, you're actively working with the ingredients to get exactly the result you want, whether that's amazing fluffy bread, a perfectly smooth sauce, or just a great cup of tea.
So we've totally solved the case of the disappearing sugar. But really, this just opens the door to a much bigger final question for you to think about. What other incredible bits of science are hiding in plain sight, right there in your own kitchen?